Hi, this is Tech with Costa, and I'm sharing my engineering journey. In this video, we are going to understand the basics of Git and GitHub with real examples. Let's create a repository where we will store everything we do for this course. This way, we have a version control of what we develop. For example, to store code, notes, homework solutions, and answers. Go to your GitHub account, click this icon, Your Repositories, New, give it a name. I will type de-zoomcamp. Give it a description, course walkthrough, Data Engineering Zoom Camp 2024 by Data Talks Club. This repo will be public to share it with others, including the course instructors. Add a README file. A README file on GitHub is a brief document that explains what a project is about and how to use it. It's like a user manual for the project. Create repository. The repository is initialized with a readme.md file. This is a markdown file, a simple text file used for writing and formatting content with basic styles like headers, lists, links, and images. It's easy to read and write, and it's commonly used for documentation on websites and software projects. Let's clone this repo using SSH. Code, SSH, select the link, copy URL to clipboard, cd into git, git clone, paste the URL, enter, L to list. Now we have a folder named Git to store all our coding projects. The de-zoomcamp repository is our personal version of the course repo to store our projects that we develop for each module. The Data Engineering Zoomcamp folder is already here from the previous videos. It's the official course repo. We will use it to follow the guidelines of the course, to have easy access to code and homeworks. Both these folders are Git repositories. But how can we distinguish between Git repositories and standard folders? Both contain a .git folder. If we type LA Data Engineering Zoomcamp, we can see the contents of this folder, and you see that it contains a .git hidden folder. The same for LA DE Zoomcamp. Let's see, for example, what this .git folder contains at the Data Engineering Zoomcamp repository. LA Data Engineering Zoomcamp.git. And you see that it contains some files and folders. You will not change these files directly, and do not delete this folder. It stores all the information and metadata about your project's history, branches, commits, and more. Think of it as the brain of your project, keeping track of everything you do with your files and allowing you to collaborate with others effectively. However, do not confuse these .git folders with our Git folder. The top-level Git folder is where we store all our coding projects, while the .git folders are like hidden control centers specific to each project, managing version control and history through Git. Now let's clear the terminal and run git status on the Git folder. We get an error because this is not a Git repository. It does not contain a .git folder to manage it. However, let's cd into Data Engineering Zoomcamp. Let's rerun git status. We get a different output because this is a Git repository. This command shows the current state of your repository. It tells you which files have been modified, added, or deleted since the last commit. Think of it as a quick way to see what changes you've made and what actions you need to take next, such as committing or staging files. We see that we are currently working on the main branch. The same happens by running git branch, and we also see that we are on main, and this is identified by the asterisk. If we had other branches, they would appear listed here. This command lets you create, list, delete, or switch branches. A Git branch is like a separate pathway in your project's development. It allows you to work on new features or fixes without affecting the main codebase. Think of it as a parallel universe where you can experiment and make changes safely before merging them back into the main code. Now let's check the commits log. Clean the terminal, git log. Commits in Git are snapshots of your project's files at a specific point in time. They record changes you've made, like adding, modifying, or deleting files. Each commit has a unique identifier and a message explaining what was done. Think of commits as checkpoints that help you track the history of your project. Each commit is signed by a username and user email to facilitate cooperation between people. This is the hash associated with this commit. This is the username and also the email, the date, and the message associated with this commit to explain the purpose of it. We can go through the past commits by hitting the down arrow in the keyboard. And this is like a history of what has been happening in this specific repository. We can press Q to quit this. We will do something similar to this in our personal course repo. In the following video, I'm going to show you some GitHub workflow examples. Hope to see you there.